Hi again, we're continuing the lecture on categorical logic. Let's move on. In the first part of this lecture, we discussed the different types of categorical claims and how to translate those claims into standard form. Now, we're going to put that knowledge to use in evaluating categorical syllogisms. Syllogisms are the heart of deductive reasoning. Syllogisms consist of two premises and a conclusion. In categorical syllogisms, every claim is in standard form. There are three terms which occur exactly twice in exactly two of the claims. As in this example, all cats are mammals, some cats are lions, therefore some mammals are lions. The terms or categories in the syllogism are cats, mammals, and lions. If you look at the syllogism, you will see that each term appears twice, once each in two different claims. This is a typical deductive argument structure. All x are y, some x are z, therefore some y are z. In order to evaluate this syllogism for validity, you'll need to figure out the major term, the minor term, and the middle term. The major term is the predicate of the conclusion. In the conclusion, lions is the predicate, so lions is the major term. The minor term is the subject term in the syllogism's conclusion, so in this example, the minor term is mammals. The middle term is the term that occurs in both of the premises, but does not occur in the conclusion, so in this example, it's cats. I'm going to stop here for a moment to bring up a very important concept that really isn't well explained in the textbook, but it's very important when you're looking at categorical syllogisms to determine their validity. A term is distributed if all members of that class are referred to in the claim. In A claims, all P or Q, it distributes the subject only. All cats are mammals lets us know that all members of the class cats are contained within the class of mammals. So when you see an A claim, you know that the subject, the thing that comes after the word all, is distributed. In E claims, no P or Q, they distribute both the subject and the predicate. No cats are insects refers to the fact that both entire classes of cats and insects have nothing in common with each other. So when you see the word no at the beginning of the claim, you know that both terms or categories are distributed, as in all of the members of each group. I statements, some P are Q, don't distribute any terms. Some tarantulas are pets only lets us know about a part of each class, not all tarantulas or all pets. Since I statements don't distribute, you need to look at the other premise in the syllogism to make sure it does. And then O statements, some P are not Q, distribute the predicate only. Some tarantulas are not pets lets us know that non-pet tarantulas are excluded from the entire class of pets. So when you see an O statement, you know that the predicate is distributed. Distribution matters because we need to be making sure we're referring to all members of a particular class. If these connections are not made, we're not going to be able to draw the correct conclusion about the validity of this syllogism. Okay, so now I'm going to take you through the steps of creating a Venn diagram to test a syllogism's validity. Here are a few things to keep in mind when you're using this step-by-step approach to using Venn diagrams. First, you need to put the syllogism in standard form if it's not already there. You need to be consistent in how the diagram is drawn. And you need to draw each premise exactly. And then you need to test the diagram's validity by looking for the necessity of the conclusion. What you're looking to see is if the conclusion follows necessarily from the premises. A Venn diagram represents the three terms in a syllogism and their relationship using three overlapping circles. And you'll be consistently assigning terms to the circles. So the minor term is assigned to the upper left circle, the major term to the upper right circle, and the middle term to the bottom circle. Then you'll draw in order premises 1 and 2 and check to make sure you've done it correctly. The circles of a Venn diagram are drawn with assumptions. All we can assume is what the syllogism tells us, nothing more. We don't know how many things are inside these circles or where exactly they are. All we know is there are either all, none, or some of these things. If we know that there is nothing in a part of a circle, that circle is shaded to show this. So let's start the process. We have to start with a categorical syllogism, so if the argument isn't already written that way, we have to translate it into one. This one's already done for us. All cats are mammals, some cats are lions, therefore some mammals are lions. Now we need to assign variables to each of these three terms. The terms are cats, mammals, and lions. We need to figure out which is the major term, the minor term, and the middle term. You'll find the major term as the predicate in the conclusion. In this case, is lions. We will assign it the letter L. The minor term, which is the subject in the conclusion, is mammals, and we'll assign an M to that one. The middle term, which appears in each of the premises but not the conclusions, is cats, which will give a C. So now we're going to draw our Venn diagram, which is 3 overlapping circles. The upper right circle is the major term, lion, so we put the L there. The upper left circle is the minor term, mammal, so we put the M there. And the bottom circle is the middle term, cats, so we put the C there. Now we're ready to illustrate this syllogism. We draw the first premise, which is all C are M. This premise is illustrated by the overlap of circles C and M. So all the cats are contained within the mammal circle. That means the rest of the cat circle is empty, so we shade that portion of the circle to show that it's empty. Now we look at the second premise. Some C are L. That part is represented by the intersection of the L and the C circles, not the blacked out part, because remember, there aren't any cats in there. The cats are in the overlap between C and M, and a part of that overlap also overlaps with the L circle. Since some C are L is an I claim, you represent that part with an X. Now you need to go back and make sure everything's correct, that each premise is valid, and you've represented it properly on the diagram. And yes, it looks like we've done it correctly. So now we can determine that this syllogism is indeed valid. What we've drawn clearly shows the conclusion to be true. The X shows that indeed some mammals are lions, because the X we put to show that some cats are lions also falls within the mammal circle. And of course we know for certain, just as general knowledge, that of all the mammals out there, some of them are certainly lions. Okay, let's do another one. This one isn't written in standard form, so first we have to figure out the syllogism. Only people who hold stock in the company may vote. So Mr. Hansen must not hold any stock in the company, because I know he was not allowed to vote. When you look at any argument, the first thing you need to do is to figure out the conclusion. Even though this is only one sentence in length, it still has two premises and a conclusion. In this argument, there is both a conclusion indicator and a premise indicator. The conclusion indicator is the word so, and the premise indicator is the word because. So it looks like the first part of the sentence, only people who hold stock in the company may vote, is the first premise. The second part of the sentence, Mr. Hansen must not hold any stock, is actually the conclusion. And the second premise is, I know he was not allowed to vote. So now we have to translate that into a syllogism. Remember, if you have the word only in a premise, it introduces the predicate of an A claim, all X or Y. So we have to flip that phrase around and turn it into this. All people who may vote are those who hold stock in the company. And we'll call people who may vote V, and those who hold stock in the company will be S. The second premise is at the end of that argument. Since we're only talking about one person here, we have to consider this person the category of people who are Mr. Hansen. Since he was not allowed to vote, this is a negative claim, so it's an E claim. No people who are Mr. Hansen are people who may vote. And we'll call Mr. Hansen H. So now the conclusion, Mr. Hansen must not hold any stock in the company, will also end up as an E claim. No people who are Mr. Hansen are people who hold stock in the company. Translated into standard form, here's our argument. All V are S, no H are V, therefore no H are S. And here's our Venn diagram set up with stockholders being the major term, so it goes on the upper right. Mr. Hansen is the minor term, so he goes on the upper left, and the people who can vote are the middle term at the bottom. Okay, I kind of combined all three steps here. The first step, to show that all V are S, is illustrated by the black shading, showing that all voters and stockholders are contained within that S circle. The second step, I show that no H are V by shading the overlap part between H and V. I didn't have to shade the whole thing because part of it's already shaded by the first premise. Then I check to make sure I've done everything correctly, which I have. And I can immediately see that this argument is invalid. Even though Mr. Hansen didn't get to vote, there's still an overlap between the H and S circles that isn't shaded. The blank part of the overlap between those circles shows us that we don't have enough information to determine whether he is a stockholder or not. So he might be. When you think about it, is the only possible reason Mr. Hansen isn't allowed to vote is that he doesn't own any stock? Maybe he missed the deadline to send in his ballot. Maybe he's running for a seat on the board and isn't allowed to vote in that instance. But we don't know. All we know is that this argument is invalid. And we do know that deductive arguments have to show that the conclusion is the only conclusion that can logically be reached. Since that's not the case here, the argument is invalid. Okay, one more time. This one is a little less clear, but it's good practice. Some modems are cable connections, and some cable connections are digital. Thus, some modems are digital. Now, that translated into standard form, some M are C, some C are D, therefore, some M are D. So we set up our Venn diagram. The first premise is some M are C, which means that at least one thing in M is also in C. But where should that X go? We're not sure. The X has to go on the line because from the premise, we can't tell which side of the line is correct. And then we draw the second premise, some C are D. And again, the X has to go on the line. Remember, our drawing can never be more precise than the premise is. So just looking at this, I hope you can see that this argument is not valid. There's no guarantee from the information that we're given that the conclusion is true. There may or may not be an M in the D circle. We have no idea. Well, I'm sure you're all very excited that we're going to be doing some Venn diagrams in class. But wait, there's another way that you can test for validity that doesn't involve drawing circles. It's called the rules method, and it consists of 3 rules that all must be followed for the categorical syllogism to be valid. The first rule involves negative and affirmative claims. Remember, A and I claims are affirmative, and E and O claims are negative. The rule states that if you have one negative claim in the premises, the conclusion must also be negative. It also means that you can't have 2 negative premises in a categorical syllogism. So first, you should always look for the negative claims. If one of the premises is negative, the conclusion has to be negative as well. And if it's not, this syllogism is automatically invalid. And any categorical syllogism with 2 negative premises is automatically invalid as well. This example is invalid because it's got 1 negative premise, no dogs put up for adoption or pedigreed, but the conclusion is affirmative. So if it meets that first rule, then you move on to the second rule, which states that at least one premise must distribute the middle term. Remember, I talked about distribution before. The middle term is the one that appears in both premises, but not in the conclusion. You need to find the middle term and check to see where it is in the claims. If it's an A claim, all S are P, it needs to be the subject of that claim. If it's an E claim, it can be either the subject or the predicate. If it's an I claim, some blank are blank, neither term's distributed, and if it's an O claim, some blank or not blank, the predicate is distributed. The example here is invalid because both premises are I claims, in which nothing is distributed. So the middle term, which is students, is not distributed in either premises, and by virtue of that, it's invalid. But But if it happens to meet that rule as well, then you move on to the third rule, which states that any term that is distributed in the conclusion must also be distributed in one of the premises. In the example shown, the conclusion is, therefore, all pit bulls are mammals. That's an A claim, so the term pit bulls is distributed. Then if you look back at the premises, the first one is also an A claim, with pit bulls being the distributed term. So this categorical syllogism is valid. Remember, as I said, a syllogism must meet all three of these rules to be valid. So when you look at one to determine its validity, you have to go through the rules in order and check each of them. And yes, we're going to be testing some categorical syllogisms in class for validity by using this method. This is the end of the lecture on Chapter 9.